Okay, so I'm Eric Coughlin from Cisco Systems. I'm a technical marketing engineer there. And I don't think I have to tell you what's changed in the industry, but I do want to emphasize that the people we're playing against are quite sophisticated, growing in sophistication, and this includes organized crime and government actors. And again, something we all know, we sort of have the perfect storm. We're in a process of changing our business processes using the cloud more, so the edge is starting to disappear. People are working from home. People are utilizing cloud services. At the same time, we're competing with a dynamic threat landscape. A matter of fact, the investment estimated, of course, in construction of malicious attacks. The investment by government actors and corporations is 2 to 3 times as great as the investment that industry is making in security technologies. So we're being outspent, and we're making the problem of protecting ourselves more difficult. So the key of this today, and I wanted to relate to that, is visibility. You have to see what's going on to start to figure out how you're being attacked. And that's actually quite hard. And I would call your attention to the second circle there. 54% of breaches remain undiscovered for months. We don't know the percentage of breaches that remain undiscovered forever. We can only guess. Now, when you have a complex problem, it's always nice to have a framework to think about the problem and the solution. And what Cisco's come up with is this before, during, and after. Like a lot of frameworks for parsing problems and solutions, it's imperfect. And some things don't really fall into this category as neatly as others. But the idea is, before you harden your network, during the attack, you want the visibility, you want the best of breed, malware, IPS, and so forth protection. And what we want to emphasize is after the attack. And this was mentioned before. You will be attacked. We have to accept that. And therefore, the quality of your and efficiency of your remediation capabilities becomes very important. And this again ties back to visibility. Can you retrospectively see what happened once you find out you're compromised? And I have a little demo to show that. Also, when you're trying to sell products or talk about products or solutions, this gives you a framework to put into place. For example, your deployment of your VPN is something that you would do before. The best of breed, email web security products from us or our competitors is something that helps you during. And after, you can do forensics and network behavior analysis and so forth. And we recently acquired a company called Cognitive Threat Analysis that does some very sophisticated stuff in terms of the behavioral analysis. They have a bunch of PhDs sitting in Prague that do nothing but think about those problems. Now, well, that was pretty high level. I want to be very specific. I want to focus on a particular acquisition that we made that has really penetrated many of our products already and is becoming our primary architecture for providing security, and that is SourceFire. So I like to look at these things from a historical perspective. SourceFire was founded by Marty Rausch in 1998, and it was Snort was created by Marty. I got ahead of myself. Snort was created by Marty in 1998, and without going into too much depth, it's both a language. You actually saw Snort roll during the demonstration. It's a very intuitive language that tells you what's in your traffic, and it's also an engine that parses the traffic so that those rules can be applied. And it It was open sourced, it's still open sourced, and Cisco is dedicated to maintaining that open source relationship, and not entirely for altruistic purposes. If you have a widely adopted open source initiative and you're driving it as a private company, that can give you a tremendous competitive advantage. So, but we're keeping this as an open source. It's got about 400,000 active members right now. And 400,000 people who are really all very interested in security, can do a lot more than any specific company could do. So that's very interesting. Also, it's fun in the sense that anything we talk about here with Snort, you Google it and you'll see long threads and discussions and people sharing Snort rules. It's really fun stuff. Well, Marty decided to monetize his creation since it was so successful, and so he founded SourceFire in 2001, and basically gave a commercial grade version of products, appliances, and so forth, utilizing the Snort architecture. But I want to emphasize, there's no branch here, and we don't have any plans to branch Snort into a commercial version of the engine of the rules and a open source version. The way that Marty described this is, he talked about an analogy to a car. He said, we're going to give you this engine for free. Now, you can go build your own car and never give us a cent. Oh, you don't want to build your own car? You want to buy a car? You know who you should buy that from? Us. Because we're building these great cars using this engine that we're not charging you for.
But the rules are going to be released at different times, right? Like
that's correct. So there's a little bit of a gotcha there. But you can get the rules pretty quickly simply by joining, go to snort.org, right?
I've been there for years.
Right, exactly.
Yeah.
And if you don't want to pay, if you don't want to even go through the trouble of joining snort.org, then you have to wait for the rules.
But eventually the rules. Since '98.
Now, here's something I want to emphasize. Snort acquired Immunet Technologies in 2011. So Immunet was essentially an endpoint product that did AMP on the endpoint. And what's really interesting about this acquisition is the idea is Snort is great at dealing with traffic, analyzing traffic. Well, if you have a product that can take a file and analyze it, why can't you carve the file out of the network traffic? Snort understands the protocols, HTTP, FTP, it can tell that, hey, this is a file being transferred. So they were able to very rapidly integrate the SourceFire, or the Immunet technology into their network product, creating what's called AMP for networks. So now we can watch the file cross. To avoid huge latency, we let the file through, we hold on to the last piece, we do the malware analysis, and if it's convicted, we drop that last piece. So by the time we acquired them in 2013, they had already integrated two technologies. When someone says, this uses SourceFire technology, I immediately ask, what are you talking about? Are you talking about AMP? Or are you talking about Snort? And notice we paid a pretty penny for this, $2.7 billion, which I think shows our dedication to really becoming a leader in security. I don't want to go too much through Snort Architecture. This could be a nice like 2-hour presentation. I gave a 1-hour presentation on this at Cisco Live, like 90 minutes. I'll do it in a minute or two. We get the packets, and we don't. And this is at this DAC level that different architectures make a big difference. I mean, I'm sorry, different hardware, because these are the libraries that actually get the packets. We then decode them. That's actually the first preprocessor. From then on, we're working with objects in memory. We've populated memory with components of the packets. And then we have a huge number of preprocessors, well, dozens of preprocessors that understand specific protocols. So we got an IP one, then you go up to the layer 4 with a TCP, stream preprocessor and normalizer. Then you've got ones for DNS, for HTTP, SMTP, and so forth. So it's really the preprocessors that understand the network protocols. Once you understand what you're looking at, you then pass it to the detection engine. And although there are actually rules in the preprocessor level, most of the Snort rules, typically we're talking about 8,000 rules, live at the detection engine. And a lot of the subtlety of the engine is building rule chains to make sure you're applying the rules in a logical way that's efficient. And then, of course, we have, this doesn't do any good unless you can output this information, either down to sort of the policy level where you start to block things or sending alerts and so forth. And there's a very flexible output module. syslog, it can send stuff via SNMP. There's this thing called eStreamer that I'm sure you know about that just sort of sends out raw data, so it's really efficient, really low latency, and then you have your receivers of that data worry about how to get that stuff processed to be meaningful. Okay, that's Snort. Remember, there are two technologies. Here's the other one, AMP. Now, the correct approach, I believe, I think most people realize this, to advanced malware, which is a moving target, is you can't really think about it as a single or a small number of successful architectures. I'm sorry, what just happened? That's okay. I'll give you an example. Sandboxing. Sandboxing may be the detection method du jour. And it's a very important detection method. And as a matter of fact, we had an acquisition recently of a threat grid to improve our sandboxing, which we're calling dynamic analysis here. That's great. But what will be the technique du jour tomorrow or next year? Well, that depends upon what the malware guys do. So we're playing this cat and mouse game. Unfortunately, they're getting pretty good at detecting that things are running in a sandbox. So that's losing efficacy. Some of the most obvious one-to-one signature. Let's just hash this thing. Most malware is known malware. It's been seen before. And that's certainly the cheapest, the fastest. You calculate the hash as you see the file on an endpoint or you see it move through the network, look up the hash. We've got tens of millions of hashes in the cloud. Fuzzy fingerprinting, the problem, this is your polymorphic viruses, but when you polymorphize a virus, there are certain things that stay the same. So if you're a little bit more careful about how you're taking the fingerprint, you can catch polymorphs. Machine learning is more like, this is virus-like. Look at the DLLs it's trying to load. Now we have never, this is not a polymorph of an existing virus, this is a new one. But this is a virus-like, or a PDF file that's starting to do all this stuff. Like, or a file that's suddenly trying to launch Wireshark. So you do this machine learning. Indications of compromise can be many things, but a good example is you see a network activity. This thing's trying to phone home somewhere, probably spyware or command and control. Dynamic is the sandboxing. Advanced, there are lots of things that we're not talking about here. There are too many, and they keep changing. Device flow correlation is actually really clever. It says, not only is this thing phoning home, but if you're sitting at the endpoint, you can say, which process did that? That's interesting. I'm looking at my device tree, and I can see that process was launched by this executable, which was dropped by this other file. So it's that other file must be malicious, because it's dropping things that are trying to phone home. Okay. And the other component is Talos, which used to be called SIO. Some people might know it as sender base. In order to understand what's going on the network, you have to have a great deal, in order to understand the modern threats, you have to have a great deal of understanding of what's going on in the world. For example, DNS sites popping up and down. Suddenly, a new domain appears overnight and a huge amount of traffic is going to it. Well, that was a successful spam attack. Okay, let's look at that spam. Let's look at those URLs. Let's put a spider on that site and figure out what new malware is there. Or it could be phishing. How do you detect phishing with antivirus? Right? That's tough. Well, you don't. You typically detect it by some sort of understanding of how the domains work, the history of the domains and the history of the traffic, and seeing the links in spam. So this is a place where companies can succeed by success. The more devices you have out there, the more traffic you see, the better context you get for the internet. So the three pillars that we have are Snort, in other words, IDS, IPS, anti-malware, this changing palette of techniques to detect malware, and security, what we could call collective security intelligence. Now we've introduced the word Talos, which is actually an aggregation of technologies and humans working together to identify threats as they emerge. Did I say Internet of Things? I don't think I get paid unless I say Internet of Things. Internet of Everything. Exciting. This is going to be really interesting 10, 20 years as the world transforms. I mean, this is just the beginning. We've just invented the steam engine. Now we're going to see railroads across the country. That's what's interesting about the next 10 years as we move forward. I mean, this is real. I don't know if all the projections of profitability for Cisco for this are real, but this is real. It's also very scary because this stuff has to be secured. And you might say, well, just don't put it on the internet. You know, that's kind of like telling the public, just don't use your credit card online. You can tell them that, but what you really end up, but since that's what everyone wants, you're ultimately going to have to address the security needs that emerge out of the fact that everything is going to be online. Now, we have some products there. I'm not going to try to sell you products. If you own some kind of a factory, come talk to me after the presentation. But what I really want to emphasize here is that the pillars we talked about are applicable. So, you know, the more things change, the more they stay the same. Snort, what does Snort do? It has preprocessors that understands protocols. What's going to happen in the Internet of Things? There are going to be some new protocols. There are actually going to be some really old protocols too, as we move into what we call operational technologies rather than information technologies. But it just means we might have to write some new preprocessors. The fact that you have to analyze protocols and then apply rules to threats that are exploiting those protocols is not new. That's not going to change. And that's what's great about Snort. You know, we were going to have 400,000 people online trying to, you know, in this community dedicated to saying, no, we have to protect our critical energy infrastructures just like we have to protect the internet.
So the rules for Snort, traditional, same rules, emerging threats.
Right, exactly. New rules for new threats.
Right, but I mean, being able to import those rules.
Exactly.
Any of the
being able to customize them yourself, share them or don't share them. As a matter of fact, we have now in Snort ways to obfuscate the rules by hashing and saying, look for this string, but I'm not going to tell you what the string is because I made an investment in that. I want to give that away. But I'll give you away a hash for the string. So just keep hashing, and if you hit this, you'll be protected. So yeah, so in a sense, like I said, the more things change, the more they stay the same. Snort is coming with us into the Internet of Things. For example, we've got a full SourceFire instance running inside our new ISA, Industrial Security Appliance. And of course, validated designs and working with partners is going to be part of this. And by the way, I didn't have this as a bullet item, but of course, visibility. So just in the Internet of Things, you need that visibility that you need to protect any sort of an infrastructure. Now, here's something really cool. That's the main reason why I want to show it. But it also emphasizes this concept of having a really good remediation technology or capabilities. Here's something in Firesight, which is you might know as Defense Center. We changed the name to Firesight, and we're changing the name again. And I don't know, I'll look up the name after the meeting, see if it's changed. We're going to call it Firepower. This is something called a file trajectory. What we do is we track a file as it moves through our network. Of course, we need visibility to do that. And here we're seeing it actually move from a web server to a client via Firefox. We look up the SHA. It's not known yet to be malicious. Now we see some maybe a little bit mysterious or suspicious activity. That client is suddenly transferring the file over SMB. That looks like an infection to me. I mean, this is fake data, by the way, in case so don't think too hard about it. But again, we still don't know it's malicious. Maybe at this point we sent it for sandboxing, or someone else was attacked, or our Talos figured out this is malware. And at 610, it's identified as malware, because we're constantly checking with what we call the retrospective queue to see if the disposition of any files have changed. What's great is we know what 4 systems have seen this file in our network. So we can limit our remediation down to those 4. Now this could be automatic. We have remediation modules that can pretty much do anything you can imagine based on any combination of events you can imagine. You know, if you can script it, you can do it. So these could have automatically been taken off our LAN, or we could send ACLs to avoid them getting to our critical assets. But anyway, the key thing is we've identified 4 systems. Not only have we identified 4 systems, but it's the second system that's been doing all the suspicious activity, but it's the first system that we have to investigate, because that's the one where it entered somehow someone compromised one of our internal web servers. So although we certainly have to remediate all 4, that we would be studying the logs on that first one. Here we see a quarantine event. How could we tell from the network that something was quarantined? Well, we could do everything except this without an endpoint agent. But we also want to sell you endpoint software. And most major vendors recognize that you really need both. The network protection is not enough, and that's why most major vendors are making acquisitions of endpoint malware solutions. And this is simply communicating that information back. And of course, maybe the punchline is, now that we know that this is malware, we're going to block any other transfers. So this is a good example of how we get that visibility to exactly where this file's been on our network, so that we can take action after we find out that we've been compromised. So the challenges. Well, everything I've shown you is expensive, particularly malware. Looking up all these hashes. And we'll sell you all the equipment you want to buy, but that's not really a scalable solution, and this is where the partnership with Gigamon comes in so well. You really need to see everything, or at least you have to make sure that you see everything that you need to see. Also, and this relates to what you guys were talking about, a downtime is not acceptable. And so when you're doing things like Snort upgrades, even though it's a very short period of time where something's down, if that's in line at your edge, you've got an issue there. So kind of managing that. And the truth is, although we tend to send all the traffic to this thing, it's maybe a small portion of the traffic that you need. And again, here's where Gigamon can come in. Also, scalability in terms of number of interfaces and real estate in like a data center. So if you go for a solution of saying, I've got a big budget, I'm just going to get a bunch of 3960s, I'm going to stick them on the edge and send everything through there, well, you're talking about a lot of real estate in your data center and a lot of upfront cost and total cost of ownership. And of course, what if you want to remove, upgrade, replace one of the IPSs? So all of these issues about scalability and cost really relate well to an intelligent third party that, like Gigamon, that allows us to be more careful about what traffic we see. And as the demo showed, we can dedicate some devices to just doing just doing malware, and put them where we think malware is going to come in, because that's the most expensive. We can do an IDS, maybe that's more for the edge, that can take a higher percentage of the traffic, and so forth. So I think this is in some sense, the Gigamon solution is just what the doctor ordered to make the very powerful but expensive solutions that we have for protecting your network feasible and with a reasonable return on investment.